Log equations. We have two types of log equations. We have one with logs on the left side and a constant on the right. And then we have logs on the left and logs on the right, and the logs have the same base. Okay, let's start with this example. Notice there's a log on the left and a constant on the right. We have to do these the way we did the first section with our first logarithm section, where we converted them into exponential form. Or we wrote it like this: the base, the exponent, and what it's equal to. Now remember, this is the base, so it's 3 squared equals x plus 1. So we're setting up a simple equation to solve. That gives me 9 equals x plus 1. I subtract 1 from both sides, so we'll get x to be 8. They have to, I have to be able to get something that makes sense. Now, let's do a few more of these. Well, come on, lady. Hold on, y'all. All right. Let's say I had log base 2 of 3x minus 1 equals 5. So that's the base. So we're going to have 2. This is the exponent. We're going to have 5. And then it's equal to 3x minus 1. That's going to give me 32 equals 3x minus 1. Add 1 to both sides. Then divide by 3. So we get x to be 11. Now, on these logarithm equations, it's important to check this right here. You have to plug this back in here to make sure you don't get a negative number. So let's go. So actually plug the, come down here and plug in the 11 and simplify it and make sure you don't get a negative number. That gives me 32. Remember back from way last week or something, whatever it was, this, when we were finding our domain, this has to be greater than 0. So we have to actually, once we solve it, we have to check the answer to make sure it's greater than 0. Check your answer. Alright, let's do some more. We'll do log of, 5 of 7x plus 4 equals 3. So 5 is the base, 3 is the exponent, and it equals to 7x plus 4. 5 cubed is 125. 7x plus 4, subtract 4 from both sides. 121 equals 7x. Divide by 7. So we'll get x to be 121 over 7. That's my answer. That's all I can do. Now, you may see something like this. You might have log base 3 of 4 plus log base 3 of x plus 1 equals 3. When you have multiple logarithms on the left side, we have to do the condensing that I showed you earlier. We have to squeeze it back together by multiplying the 4 and the x plus 1. So sometimes you may have to squeeze it back together before you can actually start solving. All right, let's go ahead and, now, 3 is the base, 3 is the exponent, and it's equal to this. So that's going to give me 27 equals 4x plus 4. Subtract 4 from both sides. 23 equals 4x. So I divide by 4, we get 23/4. So one more time. If you've got log, or if you got multiple logs on the same side, you have to squeeze it back together into a single log using those special properties. Now, let's look at the ones where we have a log on the left and a log on the right. Here's the rule. If you have logs on the left and the right, and the bases match, that's important, you can drop the log part and set the m, whatever m is and whatever n is, equal to each other. That's the rule. It's kind of like that LN method I showed you. Not LN method, the base matching method I showed you. It is base matching. So here's what I'm talking about. Suppose I had log base 7 of 4x minus 1 equals log base 7 of, let's see, how about 3x plus 5. Well, since the bases match, I can just drop the log part and bring this down, and then solve for x. Add 1 to both sides, equals 3x plus 6. Subtract 3x from both sides, and I get this. Now, it is important to check your answer when you've got multiple logarithms like this. So we've got to go up here. Let's start with this one. Let's plug in the 6 and see if it equals a positive number. 24 minus 1, 23. So that equals a positive number. Let's take the second part. Plug the 6 in. We'll get 18 plus 5 equals 23. So they are equal. But we've got to check them just to make sure. Let's say I had log base 13 of x plus 9 equals log base 13 of 4x minus 3. So the bases match. So we're going to take the x plus 9 and set it equal to the 4x minus 3. Now we're going to solve for x. Subtract 9 from both sides, so we'll get x equals 4x minus 12. Subtract 4x from both sides. Negative 3x equals negative 12. Divide by negative 3, so x will be positive 4. And we're going to check the answer. So this first part up here, if I put 4 in for x, 4 plus 9 is 13, so that's good. If I put 4 in for x on the second one, 16 minus 3 is 13, so that works. Oh, let's try this. Suppose I had this. Let's change that to a 6. Now, this is one of those deals where you've got two logs on the same side, which means you've got log twice, which means we can't do anything the way it's written, so we have to change it into a single logarithm and use the property that says we multiply those together. That should be a 1, not an x. Now we're going to drop the log part, and we're going to have x times x minus 1 equals 6. Distribute the x, and we get this. Now this is a quadratic equation. We've got to go solve this, so we've got to move the 6 over and then factor. This is going to give me x minus 3, x plus 2. When I solve for x, I'm going to get right over here. X equals 3, x equals negative 2. Now again, we've got to go check our answers, especially when you've got to factor. If I take this 3, let me change colors. If I take this 3 and plug it right here, what do I get? It's a positive number. If I take the 3 and plug it in right here, I get a positive number. So that works. Well, let's plug negative 2 in. If I put negative 2 right here, guess what happens? It doesn't work. It's a negative number. It doesn't work. If I put it in here, it's a negative number, so it doesn't work. Because it doesn't work, I only have one answer, and that is the x equals 3. Now, let's suppose I had LNs. LN of 7x minus 1 equals, oops, ln of x plus 9. It doesn't matter if it's an log or a ln, as long as they match, we can just set the pieces equal to each other. Add 1, subtract x, so 6x equals 10. Divide both sides by 6, and then simplify. So this is the final answer. And you don't have to check this one. It works for sure. But that's the whole thing. If they match the bases and everything, you can drop the log part and set the pieces equal to each other. If you've got multiple logs on the same side, you've got to use the properties to squeeze them back together. Alright, so these can be a little more complicated. I could have like maybe 2 logs on the left and 2 logs on the right. I could have 3 logs on the left and 2 logs. It just depends on what the problem looks like. But on the final, it's pretty straightforward, simple logarithmic equations. We just don't have time to do every type. So make sure that you do the homework. Try to do the homework. Email me if you got any questions and that kind of stuff. But hopefully this won't be too bad on you.